Welcome to the demonstration of the Cisco Intelligent WAN app. The Intelligent WAN app is an application that runs on top of the APIC-EM. The point behind the IWAN app is to simplify the deployment of branch sites that require intelligent WAN capabilities. There are three main components to this. The first one is a transport-independent VPN tunnel. The second is an application performance monitoring piece where we can get real-time statistics on applications and their performance across the wide area links. And the third one is a policy-based mechanism for defining QoS and intelligent path selection, whereby the infrastructure is able to, based on a service level agreement, intelligently route applications across multiple links based on the underlying performance of those links in terms of jitter, packet loss, etc. In this particular example, I have already configured my hub site. I'll show you how to do that later. I've also got a branch site configured. Branch site is called Gastiers. That actually uses the plug-and-play infrastructure as part of the controller, which was an example that I showed you earlier. And the nice thing about this is that essentially all I need to do is to plug the router into the remote site, and it will use plug-and-play to connect to the controller. And then based on a couple of parameters that I provide in the workflow for the branch, a full configuration will be deployed down to that device. That will include all of the crypto, all of the certificates, all of the application performance monitoring, and all of the policy for the QoS and intelligent path selection. I'm just going to take a look at the policy piece, because this is the really interesting piece, and the key thing here is how simple this is. So here you can see there are a couple of key components in terms of how this policy is defined. The first one is the notion of application categories. So there are a number of categories that have been defined, and inside each of these categories there are a range of applications. So inside email, for example, there's a bunch of different definitions for various applications concerned with emails. I can define new applications, I can delete applications, etc. So I can move applications around. Now the point behind this is that once you've got these application categories, it becomes simpler to manage the applications. By default, we recognize with MBAR 2 about 1400 applications, so instead of having to worry about manually configuring and moving 1400 applications, I can just manage and move an application group. These application groups are then used in the policy section. So the policy is actually fairly simple. Really, I need to make two decisions around how I treat my application categories. The first one is the notion of relevance. So do I care about this application category or not? And there are really three mechanisms of relevance. It's business critical, it's default relevance, or it's scavenger, in which case I want to treat it badly. So essentially, for those of you who know how QoS and 12 class CORS model works, you recognize these two as being the two of those 12 classes, and essentially with the relevance piece, what we're defining is, do we use the Cisco best practice for assigning QoS to this application and mark that traffic accordingly, or do we mark and treat that traffic badly, or do we just treat it as default traffic? Then once I've defined QoS, I then get to, for each application group, I get to define whether I'm using application performance or not, and I get to define the path preference. So I can specify no path preference, I can specify a path preference across my MPLS link, or a path preference across my internet link, or I can load balance between the two. So this is really as simple as it gets in terms of defining the policy. Is it relevant or not to the business? So do I enforce QoS or not? And then for those applications that I care about, how would I like them to be treated across the wide area link? Do I want them to prefer one link over the other and automatically load balance or move across to the other link if the performance of the primary link is not satisfactory? So that's really all there is to do in terms of setting up this policy. If I was to make a change to this policy, and let's say that I decided that email, for example, was no longer business critical, but in fact something that I would like to treat as scavenger, and I'm sure many people would like to do that with their email. All I need to do is to drag and drop that category across and then apply changes, and I can do this either instantly or I can schedule it to occur at a later point in time and that policy will be implemented onto the network. So I don't have to do anything, I don't have to make any configuration changes. All that happens is I need to make that change in the user interface, and that change will be propagated across the entire WAN environment. So very easy, very simple, very easy to define how the applications get treated across the wide area link. The other part of this is visibility, and this is where integration with prime infrastructure comes in. In prime infrastructure, if I go into services and look at PFR monitoring, I will get information about the two links that I have. So I've got an MPLS link and I've got an internet link, and you can see the relative reachability of those links over time. I also get to see the maximum delay, jitter, and also packet loss across those links. If I see these dots down here, these are all events where the underlying infrastructure, the network itself, has detected that for some reason an application needs to be moved to guarantee its service level agreement. And a blue dot here represents a point in time where an application is being moved from one link to another. Now, if I saw a red dot here, obviously we can't change the laws of physics. That would be something that it was unable to correct. But in this particular case, these examples are where the infrastructure itself has been able to correct the routing of the application, change the application from one link to another to provide better performance or to guarantee performance. If I click down into this, I can see the details. And essentially what this is showing me is that from my remote router, which is Gastier's, I have two possible paths back to my hub location, my head end. I've got a tunnel 10 that is going through an MPLS service provider, and I've got a tunnel 11 that is going through an internet service provider. Now, if I want to get more information around those links, I can click on them and I can get information about the bandwidth, etc. I can even analyze the performance of the link and click down. And when I click down into that link, I can see the bandwidth in and out over a period of time. I get to see the applications that have been run across that link and the relative mix of applications. So you can see that I've got SSL traffic, I've got SNMP traffic, I've got SSH traffic, which is probably not uncommon given this is my lab network. You can see here I've also got RTP audio, so I've been doing a little bit of voice across this environment. So you've got good details in terms of the traffic that has been flowing across that link at every point in time. Of course, then I can drill down and look at, for a particular QoS classification, what applications have been treated as default. So again, if I drill down and look at the default DSCP setting, I get the same information around the relative application mix over time. So I can see at this particular point in time, I've got a lot of SSH traffic. I can see how traffic has been treated across this link at a particular point in time. So a great deal of visibility, drilling down into the infrastructure and showing me exactly how the applications have been performing and what the mix of applications has been across this network. I can also go into the performance dashboard and look at either interfaces, devices, or just applications across the network itself. I get to see the top clients for across the network. I get to see the rate of traffic. I get to see application server performance, so the average, the maximum, etc. I can drill down and then see a deeper analysis of that if I want to. I get to see the top servers on the network. I get to see the top interfaces, many of which will be IWAN interfaces. So I've got a great deal of visibility in terms of how applications are being treated on the network based on the performance data that the intelligent WAN application is exporting out to prime infrastructure. If I go back to the IWAN application, I just want to show you how easy it is to set up a new location. If I look at the locations that I have provisioned, you can see my hub location where I've got an internet, my internet links. One is an MPLS service and one is a internet VPN service. And I have Gastier's, that is my remote location. What I'm going to do, just to make things simple, is I'm going to delete this particular site. I'm going to do a write erase on the router, let it come up, let plug and play do its work, and then show you how simply you can provision and put this device onto the network. The interesting thing about deleting this site is that once I do this, what will happen is the certificates for the device will be revoked. And that means that that device will not be able to connect anywhere else, will not be able to connect via the VPN into the enterprise network now. So if you look at the router I've just logged in, you'll notice that the neighbors are down for tunnel 10 and tunnel 11. And the reason for that is that those certificates have been revoked. So the device is still active, but the certificates have been revoked. So that's the reason that this neighborship relationship has gone down, and the two tunnel interfaces, one for the MPLS, which is tunnel 10 that you saw earlier, and the other for for the internet link, which is tunnel 11, the reason that those have gone down. So what I'm going to do now is I'm going to do a write erase, which is never a good thing to do to a device, and I'm going to do a reload. So you can see here we have no devices that have been newly discovered, but we only have one site that's been provisioned, which is the hub site. So in a moment or two, if I wait for that device to reboot, you should see that that device will appear here as an unclaimed device. And here you can see the device has contacted the controller via the plug-and-play protocol. It's got an IP address from the service provider. I can see the type of device, the serial number, and what I can do now is give it a site name. And a host name. If I save that, and then what I can do is I can provision the site. And provisioning is quite simple. All I need to do is to select topology. There's 3 possible topologies. In this case, I'm going to go single router with 2 WAN clouds. I can set a geolocation if I want to. I can select a POP to connect to. In this particular case, I have a single point of presence, a single hub. In future releases, we'll have multiple. And then what I'm going to do is configure my WAN links. So this will be the internet link. This will be the MPLS link. And I just need to set a location. And I'm going to, all I need to do for my internet link is just provide a bandwidth. You can see it's an Ethernet connection. I can see the interface that it's connected to. Save that. Then for the MPLS link, it's slightly more complex. I need to provide basically the CE and the PE IP addresses. IP is 10.10.2.6. Upload and download bandwidth. I can select a service provider model depending on how many classes of service my service provider offers. That's really all I need to do. I can configure WAN LAN VLANs. So this is the number of VLANs I would like to be present on the LAN side. I'm not going to change these, I'm just going to leave them as default. And now that I've done that, all I need to do is apply changes. I can schedule this to happen in the future or now. I'm going to schedule it for now. You notice that this location, this site is in progress, and we'll get to see by hovering over the I button basically how that site progresses. So you can see that the site is being provisioned because the icon is moving here. You can see that the status is in progress, and it will go through a number of steps, and that will culminate with the successful deployment of the router. You can see the device going through the various stages. If I click on the eyeing button, you can see that there's a bunch of things that have happened, a whole range of configuration that's gone on, voice and VLANs being configured. So It's gradually going through the configuration, which takes about 5 minutes, and putting all of the configuration onto the device. So you can see that that has now been successfully deployed. You saw how simple that was. If it was using DHCP for the internet link, which it was, then you can see how simple that is to do. There's basically no configuration required. Where you have an MPLS link, obviously there's a little bit of manual configuration because of the service provider information that's required, but basically very simple and easy to deploy. So the final thing I wanted to show you was just the head end and how to deploy that and how simple that is. So in this case I have actually configured the head end, but I just want to take you through the steps in the workflow. It's very, very easy. So there's some basic configuration I need to provide, which is the NetFlow collector, which is used for the performance monitoring piece, some SNMP community strings, a domain name. I can supply a syslog, etc. if I need to. The next thing I need to do is to provide a pool of addresses that are used for the overlays and the remote VLANs. I can separate these out. In this particular example, I've just put in a generic pool, but I can have specific pools for specific environments if I need to. I then get to look at the COS models for service providers, and there's 4, 8, 6 or 5 class COS models, and this is essentially how you map your QoS settings into the service provider. And the final part is just the configuration of the head end. In this particular example, there's only one POP or data center supported. In the next release there will be multiples, and all I need to do is to look at the number of border routers I have, which essentially will map to a service provider in this case. So I've got 2 border routers, one going to the MPLS service provider, one going to the internet service provider, and I've chosen to co-locate my master controller, which is responsible for the performance monitoring policy piece and the path dynamic or intelligent path selection policy piece. The MC, master controller, is co-located on one of those devices. It could be located on a separate device. I can provide certified iOS releases for my branch locations depending on the type of router I'm using in those locations. And then if I've made changes, all I need to do is apply them, and I can again configure it to happen straight away or happen in the future. So that was the Intelligent WAN app. You saw how simple it was to describe and enforce application behavior across multiple WAN links using policy. That policy allowed us to describe the QoS settings as well as the path preference based on a service level agreement, and the intelligent infrastructure would automatically reroute the applications across WAN links in the most optimal way to achieve the service level that we required. You saw how simple it was to set up a new device. Essentially all I needed to do was to plug it in, select a topology, and the device would be deployed and connected to the network. And the final thing I showed you was just the way that you set up the head end, which again was very, very simple. That's something that you do once and you can have your head end up and running. So that concludes the IWAN demonstration. Thank you very much for your time, and I hope you found this useful.